Who's gone? Back. Just Chris. Okay. A lot of people that were gone yesterday, welcome back. Glad you're here. But for the rest of us, here we go. Number 2 was just a fill-in. It was the law of signs. Number 10 and number 34. Let me give you a second because you guys have multiple pieces to grade. Check those decimals. If you were doing it like me with 3 decimal places, that's totally, it's perfect. It's fine. Just make sure that if you word around it that you would be getting exactly what they have or what they had. You guys got it? So if you notice on number 10, they use the standard form, then they use the alternate form, then they just subtracted from 180. You could have used the standard form, then the law of signs form, and then subtracted from 180, that would have worked too. Number 34, they used the alternate form because they were solving for an angle. But once again, you could have done the standard and then just moved everything away from the angle, but either way, a few of you guys might have needed to remember to do cosine inverse of both sides, because when you do the fraction, it is 0.0065, but you have to do cosine inverse of both sides to get the angle. Then they ended up using law of signs on the next one, and then 180 minus. So we're kind of going back and forth between using law of cosines, different forms, and law of signs. Number 36, they went straight to law of signs, but can you guys tell why? Why not do law of cosines? Yeah, 2 angles. If they have 2 angles, find the third angle. You can already, by finding the third angle, you can have a pair for the law of signs, and that makes that formula really nice. Actually, law of cosines would be kind of impossible, or at least really hard, because you don't have side B or side C. In law of cosines, you use all 3 sides somewhere, so. Yeah, that would have been kind of hard for law of cosines. A couple more seconds. Ready for number next one? Okay. 38 is plugging into Huron's formula. What made number 56 weird? He totally was. What made him weird? How many unknowns did you have? Yeah. Because you were missing what, 2 variables? What 2 variables are written in the equation for 56? So you're missing the angle and x. You're missing a side. You're missing an angle and you're missing a side, which made it a little rough when you went to go plug in, except they were able to, nope, they didn't. They didn't give you an angle or an x. Instead, they asked you to go ahead and plug in. Since I see the x squared and the x to the 1, maybe you thought quadratic, and if you didn't, that's what you were supposed to think. You were supposed to think quadratic, because you have that squared, and then you have a single x, and you have this term without an x. They moved it all to one side. Ooh, that's gross. Don't move it that way. They moved it all to one side. That's easier. They rewrote it in the ax squared plus bx plus c. The weird thing is when they went to this quadratic formula, x equals negative b plus 1. Wait, that's a b? Because the x is representative of the bx spot, ax squared plus bx. The x shows that this is the b term, and everything besides the x is the b. So the negative 3 and the cosine theta, they're all the b. So you have to do negative b, so negative 3 cosine. Plus or minus squared, root b squared minus 4 is b. I know it's weird, I know it's funny, but it was a way to get x by itself. And they wanted you to get x by itself, then plug it in and graph it. And then from the graph, they asked you for the maximum. We'll just use the max feature. Use the graph to find, I think the max is going on right there and or right there. You might have needed to zoom out just a little bit to be able to find the max, but the max ends up being 1, 2, 3, 4, 5, 6, 7, 8.5. 8.5. Sounds a little weird. Need a quadratic formula. Number 66, how'd you guys do looking at the FSS, the AAS, the SSS, SAS? Made sense? Law of cosines loves sides. Law of cosines loves sides. Law of sines helps us with the case 1, case 2, with the ambiguous one. That's why we did law of sines there. Could have done law of cosines, but it would be one of these nasty quadratic-y ones. Most of you wouldn't like that. So law of sines is probably the easiest, and then AAS, law of sines loves angles. I think we actually had those little, what are they called? Acronyms? They wouldn't be an acronym, would they? In our notes, we actually put down which one was best for each one, so hopefully that helps a little bit. All right, kiddos, I think that's the last even, but it doesn't mean that was the end of our questions. So, I heard you guys talking about word problems in section 6.2. Did I give you only... There's a notebook. Somebody leave a notebook in a pre-cal book? It's there if you want it. Were there any word problems that you guys wanted to go over?
15.
15?
No, 51.
51. Okay, anything else besides 51? I pull up the book, but you guys realize that file's like corrected. 51, 55,
25.
oh, 51, 25. Oh, he's a weird missing one. With the parallelogram, yeah, that one's kind of nasty. Anything else besides 25 and 51?
Do I get a list of the formulas?
Yeah.
Thanks for reminding me.
That rarely happens on a test, and so I don't remember when.
Not today yet.
Not today, it's just okay. If you guys figure out any other questions that you have, we can look at it, but otherwise, let's go look at our homework questions. I'm trying so hard. What next? There we go. So number 25 came first. That was the parallelogram one. How's the parallelogram slant? It's like
Oh, it's like crooked too.
the diagonals are the lines that cut it in half, right? Okay. So they're going to give us a few different things like, what was the angle that's the upper left-hand corner? Didn't they label that for us? What Greek letter is that though?
Straight line.
Not theta. Doesn't theta go straight across?
Was it 5?
Yeah.
E5.
D5 Botham. I smell the blood of an Englishman. Anyway. Then a bottom left-hand corner. Come on, you guys have read that thing and stuff, right? Is that not a thing that works? Never mind. Then we have C and D. Are those the entire diagonals? Can you guys tell? I think they tell you up above. C and D, the entire length? Is C the longer one or the shorter one? Longer one, and then D is the shorter one?
Yeah.
Okay. Some of you might have remembered this from geometry, some of you might not have. Does anybody remember the relationship of, or what's special about the diagonals of a parallelogram? What do they do? They're not congruent because think a parallelogram is tilted. So one's going to be longer, like from the pointiest, like the outermost edges. One's going to be longer, one's going to be shorter. So not the same one. Diagonals of a rectangle will be the same one. But what do they do to each other? Not complementary, those would be angles. C and D are sides. C and D are actually like little sticks, little lengths. They're not angles at all. So they can't be complementary, supplementary, obtuse. They're not angles. I mean, they're 180. I guess we could say they're 180, but no, they bisect each other. They bisect each other, which means that this little guy is congruent to that little guy, and this little guy is congruent to that little guy. So how is that special? Well, don't they tell us something about in number 25 about theta being 45 and then A and B being 5 and 8? Okay, so if A is equal to, help me out, you should have written it down, A is 5,
Yes.
B is 8,
Yeah.
okay, and then theta is
45.
45. Good. How does that help me? What are they asking me to find? There's like some blanks that are not filled in, right? So who am I trying to find? C? And then B, just those three?
Yeah.
Okay, so we have this angle and then we have those two side lengths. Would phi be 45? No, phi wouldn't be 45. But if this guy's 45, what else can we say? Parallelograms are parallel lines, right? Can't I say this entire opposite one is going to be 45 also?
Yes.
I can say that because alternate interior angles, the sides of a parallelogram are parallel, hence the name. I can say this angle is congruent to that angle, this angle is congruent to that angle by alternate interior angles, which means the whole angle is congruent to the whole angle. Now how does that help me find what phi would need to be?
Phi is congruent to the, one that's across.
How many angles are in a rectangle or a parallelogram? There's 360 degrees in a circle. There's 180 degrees in a triangle. So how many degrees are in a rectangle?
360.
Think of it, if it's a rectangle, isn't it 90, 90, 90, 90? If it's like a rectangle, it's nice and straight. So there's 360 degrees, or you can think two triangles. Although that's a bit tricky in the sense of you can't like count up all of these because these angles aren't a part of the parallelogram. If you take it half and half, then you'll have all the angles. Anyway, 360 total. So how could I get phi if I know that this one's 45 and that one's 45? Yeah, subtract. So I have 360 for the whole thing. Subtract the two 45s. Isn't that subtracting 90? Oh, and divide by 2 because there's 2 of them. Good. So 360 minus 90, 36 minus 9. Isn't that 27? 270? And 270 divided by 2, good, it's 135. There's 5. We just had to think about not a triangle, well, two triangles making the parallelogram. That might help a little bit. So now we know our angles. What about C and D though? Man, if only C and D could be like, I don't know, sides of a triangle that we could solve for. What do you guys see? Yeah. Because can't I say that 5 and 8 and whoever this guy is that D? 5 and 8 and D can be a triangle?
Yeah.
Ah, perfect, golden. And don't I have side angle side? Yeah, I used to follow cosines. That'd probably be the easiest way. So you can use law of cosines to be like, oh hey, D squared or D is equal to the square root of. Do you guys know law of cosines well enough to fill it in?
5 squared.
5 squared?
Plus 8 squared minus 2 times 5 times 8 times cosine 45.
There were a few people that were saying it. Just saying you kept it going. Because D is the side opposite the 45, right guys? So I needed that to be on the bookend with 45, but it's D squared, hence why I square rooted it. And that would solve for it. This isn't odd, you guys can check your answers, but that would solve for it, plug and chug it. How are we going to find C though? He's not a part of that triangle, is he? So what are we going to do? Look at the other triangle, yeah?
Yes.
So the other triangle will be 5 and 8. Hey, that's 8 too, right? Just pretend that's nice and even. And then C? Hold on, whose angle? Oh, hey, that's 5, right? So I can use 5 and 8 and 5, or 5 and 8 and 135, yeah? So I can say, let's see if the rest of you guys, Lane, you're not allowed to say it this time. Oh, good job. Help out. What's C going to equal?
5 squared plus 8 squared minus 9 times 8
Yeah.
35.
Okay, 45 is for that one, 135 is for that one. Got it, done. Plug and chug. Number 25, done. Got it. So, we also have number 51. Here's a little bit different type of a problem. That's not what my book is, it's over here. Okay. 51 says the following. That's the one with Minneapolis, Albany, and Phoenix?
Yeah.
You guys have to play with your geography a little bit. Minneapolis, what state is that?
Minnesota.
Hey, Albany?
New York.
Albany?
New York.
Phoenix?
Arizona.
Look, we know the ones on the west coast. Okay, so anyway, well, not west coast, but never mind. It's a triangle, right guys?
Yeah.
So help me out with that. I'm gonna go super crazy, but Phoenix down there, Minneapolis is over there, and then Albany is up there somewhere. Okay, so, question, what's from Phoenix to Minneapolis?
220.
16?
Yeah.
16.
Hold on.
Oh, wait.
Yeah, 216 mm.
Yeah.
Yeah.
What's that?
No idea.
Oh! Makes so much more sense. I was like, millimeters? No way. It's a map and it's to scale. Okay, not to scale. Anyway, I didn't realize you were talking about a map. That's weird. 165?
Yeah.
36?
8.
What are they asking for?
Angles.
Yeah, we need some unknowns. Now, I'm gonna be really careful with the wording though, because the wording is super important. You're right that we need to find the angles, but the first one says bearing from, super important. Bearing from what?
Minneapolis.
To. There's a from and there's a to Phoenix, okay. Isn't the airport code like PHX? I think so. Oh, Minneapolis as well. Okay. So from, where are you starting at?
Minnesota.
Basically, Minneapolis, Minnesota. So that's why I'm gonna mark the north-south line at Minneapolis. It's saying if you were, I would say a plane, but this would be very dangerous in a plane. So if you're in Minneapolis and if you had a compass and you wanted to turn to go north and say, okay, in what direction would I need to start walking to get to Phoenix? Awkward, I know, but that's okay. Walking to get to Phoenix. We want to know what angle would you have to turn from north to start heading directly to Phoenix, regardless of
Southeast.
different landscapes.
Oh, wait, west.
Southwest.
Yeah.
Stop judging.
Yeah.
Stop judging. Okay. So anybody have any ideas how we can actually find this thing? We need to know this angle, yeah? Okay, so then maybe we go ahead and set this up to be, wait, why am I doing 368 squared equals?
Oh, did you add 216 and 165?
Actually,
No.
oh,
I didn't even see it.
so much whispering, I'm not sure it's all productive. Okay, so we have 368 squared because I want that opposite angle. I could go ahead and call it what? M for Minneapolis. Anyway, so that'd be 216 squared plus 165. Wait a minute, hold on. Isn't there a nice way of setting up the formula when I'm solving for an angle? Is anybody even memorizing that?
Yeah, the cosine.
It'd be cosine,
And
magically turn purple. Second. Okay, cosine of my unknown equals, how's that formula go?
165 squared.
plus 216 squared.
Take away the opposite one, right?
3 squared.
All over.
2
165.
Sorry, yeah. And multiplication's commutative, so we could have done that in any order, but we need this guy to be the minus one. How do I solve for n? I solve it by, a lot of people miss this, cosine inverse. Okay. Now pause. After I find m, shush my whispers over there. Okay. After I find m, they want the bearing. So does that actually help me?
No.
It kind of does, but in a compass, how could I use that? You guys see the line between Minneapolis and Albany?
Yeah.
What does it seem to be? Due, maybe they speak in like compass talk,
Oh,
navigational talk. It's due
Due north.
east.
east.
We're not going to Canada.
Red, so look.
Never mind. Minneapolis to Albany, we're going due east. So due east, doesn't that mean that this is 90 degrees?
Yeah.
Okay, cool. And then we have that this is, oh, we haven't solved for it yet. Whatever M is, couldn't we go ahead and take M and say that the bearing could just be M plus 90? That's one way. A compass bearing says we'll turn from north, meaning we don't know exactly how to do the whole southwest thing. So we could just say, whatever, we're going to start from north, and we're going to turn the 90, and then we're going to turn the M, and then that'll be our bearing. That's one way to do a bearing. The other way to do the bearing, we need to know the south line. That would get a little bit more complicated as to how this angle was split up. So probably the easiest way is just to take that angle M and add the 90 degrees from up here. And say, let's go ahead and turn. Let's go ahead and turn that full angle. If you guys did want to do the other one, probably the easiest way would be to extend this east-west line, because that would be your west and this would be your east. You could go ahead and do 180 minus M. That'd be the other way. You could do 180 minus M, and then that little extra angle that you would have, we could call him something else. We'll just call him theta. We could say, the other way of saying a bearing would be, wouldn't that be turning west? Be really awkward. West, theta, south. That'd be kind of awkward, but we could do that. We could do that. Or we could find theta and we could do 90 minus theta. So we could do south 90 minus theta west. That works too. Because once we find this guy, then we can figure out that that whole thing needed to make 90. There's a lot of different ways of writing bearings, sadly. The west-south one is the easiest as far as math, but it's really awkward. You almost never see that. It's always southwest, not west-south. But I would probably say either this one or this one are good. Letter B, what's it asking for? From Albany to Phoenix? Let's see if this is any easier. So from Albany, where am I marking my original north-south line? Yeah. I'm going to do different colors for sake of illustration, but my picture just disappeared. So imagine you're standing in Albany, having to turn and just start walking towards Phoenix, or at least you're trying to figure out where would the direction be. You would need Albany's north-south line. There's north, there's south. What angle would I need to turn from north? That's one way. But actually in this one, I think it's even easier. If you find the angle in the triangle, wouldn't that just be the natural? That's a west-south. That's kind of awkward still. But we could still find that. We'll call him like alpha or something. We could find that angle of the triangle. We'd have to use law of cosines again, but we could go ahead and do that whole cosine of whoever that guy is, alpha. We would go ahead and plug in using these two sides. That's the original squared ones. Minus the 216 squared. I'm just filling in because you guys already practiced this formula. To solve, we already talked about how you would need to do cosine inverse both sides, right? So we can spell it. And once you have alpha, you could just say, I want that starting at south and turning west. I couldn't use alpha because that starts at west and goes south, so I'd have to do instead 90 minus alpha. So I could say south 90 minus alpha degrees west. That'll work. He's a little bit easier. Because the angle in the triangle is the one that you want. You just need to do 90 minus so that you can start at south and turn west. Because starting at west and turning south is kind of awkward, but anyway. There we go. Kiddos, this was an odd too though. In the back of the book, did they have the whole southwest thing or did they just have like an angle for number 51? Ooh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Out of 23 kids who are supposed to have this homework totally done today, An odd problem that you could have checked in the back of the book and in Calc Chat. I just asked the question, what does the answer look like, and not one person could answer me. How should I feel as a teacher? Huh. Do you guys ever think about, like, when you're just at home at night, being like, do I want to be a teacher? And you're like, I don't want to have to put up with kids like us.
Yeah. Yeah, I do.
Okay. Just take a second, have a little bit of consideration. And then, if you do have an answer, just have the courage to step up and say it. Does anybody know, for number 51, what the answers looked like? Was it just an angle by itself, or did it have south and west in it? Wow. All right.
They have the north and east.
It had the north and east on it?
Yeah. Says north 59.7 for A.
The Minneapolis, did you guys get the column to be wrong? Is it not Minneapolis to Phoenix? Was it Minneapolis to Albany?
No, Minneapolis to Phoenix. And the bearing of Minneapolis from Phoenix.
Wow, so the back of the book was wrong. So we're not going east, are we?
Page A127.
Thank you. Is that why you guys were confused? If it said northeast and not southwest?
Can you check?
Calc Chat has odds. Well, I don't like the answer because it's bad because we're not going northeast. If we're going northeast, that's a little awkward. We're going away from Phoenix. All right, well, I'm going to go ahead and get back to the notes. For vectors, I'm going to go check out Calc Chat and see if there's a typo in there that they didn't realize. You guys all agree with me that Phoenix is southwest of Minneapolis, right?
Southwest, yeah.
Are we sure?
Unless the to and from was different. Was the to and from different?
It's
Yeah, I'm pretty sure
Minneapolis from Phoenix.
Yeah,
You guys kill me.
it's going the
Oh my
opposite
God,
way.
it says from Minneapolis, same thing.
All right. Let me be real with you then, okay? When we do homework questions, and when I'm up here asking for advice and not looking at my book over there, and you guys saw me, I've tried to bring up the book and every time there's a word problem, the whole page blanks out and it won't show it. You've seen that, right? Okay. Can I magically make the computer be nice?
No.
No. And some of you are like, well, I can help. Great, come in after school and you can help all you want on that PDF. I don't know why it's all messed up. Actually, I purchased that copy. It's a bummer. But coming back. So I'm asking for help when I make this thing. Now, I figured out where Minneapolis and Albany and Phoenix were. Those were the important cities. You guys were very helpful with labeling the 165 and the millimeters. I was like, what weird map? I went over and looked at it. But when I asked, and I said from and to, I assumed that's what was there. Was I right when I said from and to, standing up here and assuming what was there?
No.
No. You guys ever assumed something and been wrong?
Yeah, all the time.
All the time, right? It happens a lot. So I assumed and I was wrong. Now, thank you for telling me the Minneapolis and the Phoenix, but did anybody look at their directions that should have been written in their homework and say, wait a minute, the from is actually right before the Phoenix? Why does that make such a big difference? Remember, I said it's super important that we get the order right. I said that like 2 or 3 times. Why is it super important for you guys to have corrected me and said, no, the from is here and this is of? Completely opposite in that I needed to find this angle. Struggle. Oh well, long story short. Our math was great if we were going from Minneapolis to Phoenix. In that, we would have kept the southwest one. But since they wanted the northeast one, then instead what we probably should have done would have been to solve for, well, I guess we can actually take our answer and use it because it'll be the same. It's alternate interior angles. Anyway, all right, fine. Yeah, alternate interior angles. See, this guy will be congruent to that guy. So that's cool. We'll just say, you know what, not the southwest. We'll say north. 90 degrees, go find the theta we were talking about and make it east. Lucky, but still, it would have been wrong the other way. Do you guys understand how important the from and the to is when talking about angles and bearings?
Yeah.
All right. Lesson learned, hopefully, even though we've been learning the same lesson all year. Thank you to those of you guys that were participating. It's not necessarily your fault. I'm sorry that I didn't read the problem and have it memorized when I walked up there. But once again, do I ever try to say that I'm perfect and never make mistakes, especially when I'm not even looking at the problem? No. So do I welcome your guys' input and correction? Yes. Please do. Let's get Christine from yours because she's ready to get them. Not ready to get them, but in a little bit she will be. Can you guys pass that back? Okay. Vectors. You guys were so excited at the beginning of class when I started talking about vectors. The problem is, I think only half of us actually remembered what was said. So, besides the oh yeah, which is great and all, but besides that, mathematical term for an arrow. Does that arrow go on forever from what we saw yesterday? No.
It's a segment.
It is a segment,
Not a red.
just with an arrow that shows the direction of the force or of the velocity of the direction something is headed, etc. So it is a set segment with an arrow that shows the direction, okay? And standard position of a vector, first of all, do you remember I said yesterday the book is going to show a bold letter? But how are we going to do the handwritten notation? Draw the little arrow on top. Now pause. Does that mean when you're writing down a problem, the directions, etc., that you're just copying the bold letter?
No.
No. You're reading the bold letter and you're writing it with an arrow, right? Okay. So handwritten notation, little arrow on top. Standard position of a vector puts the, do you remember what this is called, the initial point? What's this part of it? Tail, good. Think like a dog, tail's on the back, right?
Yeah.
So if it's headed this way, tail's back here. Or a comet, tail's on the back end, right? So I have the tail back here. Standard position of the vector says, hey, the tail is at the origin. The tail is at the origin, standard position. The head, remember, it's kind of like a point, we just don't really show it, we just put the arrow instead, but the head would be like the point that marks the ending of the vector. It's pointed somewhere, I don't know where. It could be pointed at any, or in any direction. And the direction, standard position, is being measured from due east, or measured from the positive right-hand axis. Unless it's something to do with navigation, they might do the standard position as like starting from south and heading east, or starting from north and heading west. They could have it start somewhere else. But standard position, mathematical standard position, would just be starting from the right-hand side of the x-axis. When you guys write this bold letter, right, with the arrow on top, handwritten notation. If I was trying to talk about vector v, there are a couple different ways of talking about it. I'm going to introduce one type of notation now. One type of notation doesn't talk about vector v as equaling the diagonal line necessarily, but instead it says, hey, horizontally and vertically, how do I get there? It does say horizontally and vertically, how do I get there? We're going to talk about it, I think, in a couple pages. But we can call these the components. The first component will be the horizontal portion of it, or the horizontal length that you would need to go to get to the head of the vector from the tail. B would be the vertical distance that you would need to go to get from the head to the tail. That looks an awful lot like an ordered pair, right guys? But is it technically? No. Because it doesn't just represent a point. Do you guys get that? It doesn't just represent a point. It represents a movement from a beginning to an ending. Does that kind of make sense? So from a beginning point, from a tail, from an initial point, we could call it, moving a displacement of A, a horizontal displacement of A, and a vertical displacement of B. It represents that whole line. Another way of writing vector V is that we could say vector V has a magnitude of, and we'll fill that in, but it also has a direction of. Now the direction is pretty easy, because the direction is just your theta. The direction is just the angle that you rotate. The magnitude is a little bit harder, because the magnitude is actually talking about the length of the vector. But if we do have these horizontal vertical components of A and B, we could just say it's Pythagorean theorem, A squared plus B squared. square rooted. Now, over here on this page, it starts talking about magnitude in a little bit more detail. So, quick reminder, magnitude is the length of the actual vector that's being drawn, but it could represent, remember the how muchness? I think I even put that. It's the how much or the how muchness of force. So the length 10 could represent 10, well, not meters or miles or feet, but it could represent something like 10 newtons, which would be a unit for force. Or it could represent 10 miles per hour, which could represent like velocity. It could represent like 10 feet per second squared, which could represent an acceleration, etc. So it's just whatever that length is represents how much of whatever quantity the vector is showing. The notation for magnitude is basically, you can think of it as double absolute value bars. That's not truly what it is, but that's the notation, double absolute value bars, double bars. And so we can fill in that a squared plus b squared. Now hold on, wait a minute. All of a sudden we have this PQ thing going on. In geometry, when you saw two letters like that, what was it representative of? What was it showing?
The angle.
Not even the side, like, it was a side, but who's the P and who's the Q? Points, yeah, the point at the beginning and the point at the end. So come back over here and say, oh, all of a sudden we're calling this guy PQ, all right. So we're calling this guy PQ. So technically, since we're calling this guy PQ, here, check it out. P could have come with its own little point, x1, y1, and Q could have come with his own little point, x2, y2. And if PQ came with each of their individual points, a way of solving for AB could have been, okay, let's just go ahead and subtract the two x's and figure out how much horizontal distance there is between them. So it could have been x2 minus x1. And then to get the b, we could have gotten it from just subtracting the y's. What's the vertical displacement? Make a little bit more room. But to get the a and to get the b, you just don't have to get it over at all. Love technology and hate it. So to get the a and to get the b, we could just subtract the x's and subtract the y's. It's kind of a shortcut of getting it. Which means, well, if the whole idea of the magnitude is the square root of a squared plus b squared, couldn't we also say it's the square root of, hey, this formula should look pretty nice. Just the distance formula. Oh, that makes sense. We've seen before the distance formula is really just Pythagorean theorem. And then we have this little illustration that says, oh, hey, equal vectors, to make the vector be the same, it doesn't have to be in the same place. Now, that's really weird for us. In the unit circle, to have the same angle, we have to be at the same location. In order for, on a Cartesian plane, a point to be the same as another point, it has to be in the same place. Vectors, all they need to be is, or all that needs to be true is that they have the same magnitude, same length, and same direction. Guys, I cloned these. I copy and pasted them. Are these equal? Oh my goodness, calm down. I copy and pasted them for the fact, or for us to be able to say, are these truly equal? Yeah. But they're not in the same place. It doesn't matter. They have the same magnitude, the same length, and they're pointed the same direction, meaning they're at the same rotation from the due east of each of the individual vectors. They have the exact same rotation angle. So it's not like there's one big and we're measuring it with one big x, y. We're thinking about them, in a sense, individually. So when we get to this example right here, and it's like, hey, show that these two vectors are equal. We need to say, okay, well, for them to be equal, they need to have the same magnitude, and they need to have the same direction. Have the same magnitude, have the same direction. Ooh, but I don't know the A and I don't know the B. Well, what can we do to find magnitude? Basically, yeah, because the magnitude of RS, don't forget your notation, is going to equal the square root of, well, can't we just do the x2 minus x1 plus y2 minus y1? And what are we going to compare that to? Well, the magnitude of the other guy, of PQ's vector, using the exact same formula. Guess what ends up happening? It ends up equaling the same thing. That's gonna be 3 squared, 2 squared, oh yeah, 3 squared, 2 squared. Magnitude ends up being the same. Ooh, but how am I gonna figure out direction? Can't I make little right triangles? I'm gonna make little right triangles real quick before we leave, the last thing. Go ahead and pack that, it's okay. What trig function can I use if I care about, or if I have, the opposite b and the adjacent a? Cosine. I think tangent might be the easiest. Alright, cool kids. Thankfully, no homework questions tomorrow. No, you guys just watching me mess up, we'll get a lot more done. Bye, guys. Bye.
Yeah, really.